Let's go do some stalls and falls in the mighty Luscombe today. A lot of you are seeing me fly the Husky here on YouTube and asking, what's going on with the Luscombe? Do you still got it? Yeah, we still got it. It's just such a sweet airplane and a great trainer. I'm hanging on to it. And I've got the hanger to hang on to it as well. But what that's also telling me is a lot of folks aren't keeping up with the Blanco Lirio channel. And I get this request or this question a lot of times. I'm not receiving all my notifications. Remember, you got to check all your notifications on all your devices, especially when you switch over to your telephone or something else. Each individual device, every time you download some new software or upgrade something, and or YouTube itself messes with the subscriber base, the notifications need frequent updating if you want to keep up with what's going on here on the Blanco Lirio channel. Every month we read about accident reports where people are stalling their aircraft in the traffic pattern with no mechanical problem, no emergency, just simply stalling the aircraft and crashing in the traffic pattern. Stalls and falls are something you need to practice on a regular basis. It's not just a minimum requirement to get through your private pilot test or ground school or flight test. It's something you should just practice on a regular basis. Every time I pick up a different airplane, the first thing I do is a series of stalls and falls because every aircraft is different. The POH will give you a stall speed, but it's probably likely not very accurate. Every aircraft is rigged differently, and every aircraft has a different pitot-static system, and the reliability of the airspeed is generally in question. So you need to know at exactly what indicated airspeed this particular aircraft that you're flying today stalls at. Now, lesson number one, remember, an aircraft can stall at any indicated airspeed and at any attitude. I don't care if you're going straight down towards the earth, you can still stall that aircraft, but it will only stall at one critical angle of attack. So what's a stall? It's when the aircraft exceeds the critical angle of attack or the wing exceeds the critical angle of attack and the airflow simply separates from over the top of the wing. The wing no longer is flying, it's stalling. Most light aircraft have very gentle stall characteristics, and here's some things that designers do to create gentle stall characteristics. One is the twist in the wing, or wash in or wash out. The wing on the Luscombe, as you can see here, is twisted such that the tip of the wing has a lower angle of attack than the root of the wing, so that the wing will stall at the root first and continue to fly out here at the tip, still giving you some directional control in very, very slow flight. The wing does not stall all at once, and you want both wings to stall approximately evenly so that the aircraft stalls straight ahead without dropping one wing or the other. However, this action can be exacerbated by the use of the ailerons. For example, if this right wing begins to drop and you add this left aileron input, you are increasing the camber of this wing, and that will instead cause this right wing to stall first. Now, when a wing drops in a stall, it's a natural pilot instinct to pick up that wing, just as it is if you're starting to fall and you throw out your arm to catch your fall. It's the same natural instinct. By adding ailerons, you're not only increasing the camber of the wing, but that is also increasing the amount of induced drag on this wing, which is also increasing the amount of adverse yaw that the aircraft is subjected to, pulling this wing further back and exacerbating the entire situation. So what's the solution to preventing wing drop during stalls? Keep the ailerons neutral and instead use the rudder. Now this is the point where students are beginning to get nervous, maybe even CFIs. What are the two ingredients to a spin? Stall and yaw. Uncoordinated flight will get you into a spin, potentially. What's the best cure to prevent uncoordinated flight? Fly coordinated. Step on the ball. When this ball slides out of the center, You literally step on the ball. If this ball goes this way, you need left rudder. If this ball goes that way, you need right rudder. Soon you'll develop that feel in the seat of your pants. On a metal wing aircraft, the amount of twist built into the wing is set at the factory. But on a ragwing aircraft or a fabric wing aircraft like the Luscombe, you can adjust this wash in and wash out by simply adjusting the length of this rear strut. If you extend this strut, make it longer, you will increase the amount of twist in the wing. Conversely, decreasing the length of this strut will decrease the amount of twist in the wing. And the idea is to set them up equally so that the aircraft stalls evenly without dropping one wing or the other. Another thing designers do to create benign stall characteristics in the aircraft is the relationship between the angle of incidence of the wing versus the angle of incidence of the horizontal tail. Remember, the tail flies downward. The tail provides a lift in the downward direction. The wings, of course, lift upward, and the relationship between the two provides the positive dynamic stability of the aircraft along the pitch axis. So in a well-trimmed aircraft doing power-off stalls, initially the wing will begin to stall here in the wing root area first, creating a burble over the horizontal tail of the aircraft. Next, because of the angle of incidence and the relationship between the angle of incidence of the tail versus the wings, the horizontal stabilizer will stall. As that horizontal stabilizer stalls, it's no longer lifting down, the nose of the aircraft drops, the airspeed increases, the wing begins flying again, and shortly followed by the tail flying again. And so if you keep this up with the power off, stick all the way back, the wings will just begin to stall, then the tail will stall, and then the wings will stall, and the tail will stall, and you'll just begin this teeter-totter, this well-balanced teeter-tottering down without ever completely stalling the entire wing. That's a well-designed, well-trimmed, and well-rigged aircraft. So let's go up in the mighty Luscombe and show you what I'm talking about. Before we blast off here, I want to share with you something I recently downloaded and was so impressed with that I reached out to the owners, and we've now reached a sponsorship agreement with the Blanco Lirio channel, and this is the Finer Points Private Pilot Ground School Flight Training app. This computer-based training is the way of the future, and we have CBT or computer-based training in the airline industry, but it is nothing compared to this. Each lesson is broken down. Well, he's got knowledge, skills, and scenarios. And the knowledge is where you learn your private pilot written material, as well as what you need to know for your actual practical test. And then in the skills department, they've got everything you need to know to properly execute the maneuvers to FAA standards. So unlike listening to an old guy like me out there who's forgotten more than I remember from a private pilot's license 40 years ago, this will tell you exactly what the FAA expects from you on your check ride. And included in this app is all the resource material that you need for your exam, for your entire private pilot's license. So there's a brief. He'll start out with a little video introduction from a real professional CFI that's current and qualified to teach this stuff. Then you get a quick review of the lesson. Then he's going to tell you what he's going to tell you here in another briefing and take you up in the actual airplane and shows you how to do it just the way the FAA wants to see it done. Review of the common errors, a debriefing video of some of the errors that Jason, the CFI, has seen over the years. You can tell it's authentic because he's working out of a trailer. And he gives interactive lessons like this, where you tap on the area to get it right, and if you get it wrong, here's the source material, here's what you need to review, try again. And then you get to the question and answer period, and here's where you have all of the questions that are possible out of your private pilot ground school written exam are displayed here. And over here on test prep, you can review all of those questions until you've got them all figured out for your private pilot written exam. And there's all your resource material, all the books you need. And this is interactive so that, or it's a subscription service so that it continues to get updated with new information all the time. And it costs about $150 for 3 months, $300 for a year subscription, and there's a 3-day trial period via the Apple Store. So try the 3-day subscription, see what you think, let me know what you think. The Finer Points Ground School, just a fantastic new program, and the easiest way by far to learn everything that you need to pass a private pilot written exam and practical evaluation.
All right, there's 5,500 feet. We're up over our fields now. Let's take a look on the foreflight. Looks clear of traffic. Let's do some clearing turns. Temperatures and pressures looking good. Look around here to the left. Give it a good 90-degree turn. Look around here to the right. Good time to practice some coordinated turns. And all the way around this way, got this overhead window here. Looks good. And let's turn it around for the camera to get a better angle. I'm wearing my shorts today and my white socks, so hopefully you can see my rudder action a little better. Stalls and falls, we'll start with your standard power off stall. Get that nose right up there, power coming back. Here's that carburetor heat we were talking about. Back and down she goes and recover. Nice and straight and level. By the way, how do you notice the decrease in performance on your engine with the application of carb heat? On a fixed pitch prop, you're going to notice a decrease in RPM, probably about 100, 150 RPM. Let's try that again. Power off, nose up. See that right wing drop? Get that left rudder, left rudder. There you go, save it, right rudder. Save it. Don't mess with the ailerons. You'll just exacerbate the situation. Let me demonstrate. See if I can crank that aileron in there. Well, I got back to flying speed too quick there. Let's do it with some partial power. Try to hold it up there. Now, if you try messing with the aileron, see that right wing drop, left aileron? Yeah, because you're increasing the camber on that wing. You got to use rudder, not ailerons. So let's see if we can hold that wing up a little more with the rudder. There is no stall warning horn on this aircraft. Instead, this aircraft is rigged such that you get an excellent stall buffet feedback right to the stick. This airspeed is notoriously unreliable. I'm not even looking at the airspeed. I'm feeling the aircraft out. I'm looking outside and feeling the aircraft. See how way off that airspeed is? Way too low of an indication. Feel that? Get it. Rudder, 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 rudder. Let's try some turning partial power stalls. If you're going to turn to the right and you're about to stall the airplane, which wing do you think will most likely drop first? The inside wing or the outside wing? See that? There goes the outside wing. Right rudder, right rudder. Boom. Why? Because you're increasing the camber on that outside wing by lowering that aileron. This is why you don't want to use ailerons during your stall recovery. Right hand turn. Keep it coordinated, Brownie. She's in the buffet. And there goes that right wing. And I'm forcing it with the rudder. All right. Now let's try it around to the left. Altitude's good. Clear of the traffic. Keep it coordinated. We're also coordinated against, or for torque, left turning tendencies, low airspeed, higher power setting. Since I'm turning with torque, this whole exercise goes a lot better, but there goes the right wing. And there goes the right wing. The wing with the down aileron is the one that's going to stall first in a turn. Why you don't want to use ailerons in a stall. Just use your rudders. So let's do some slow flight here. Well, let's look at that number. Let's actually look at the airspeed this time. That's 25, 30, yeah, it's way down there. Like around 30 or so, 35, all right. So let's slow fly here at 45 indicated according to this airspeed indicator. Let's get enough power on it so we're not losing altitude. We set a hard altitude here of 5,000 feet in this practice area. If we get down to 5,000 feet, knock it off, climb back up. Get back over here to our emergency fields. We also got the highway over here. If you have a cylinder head temperature gauge in your aircraft, now's a good time to be watching that because low airflow over the engine is going to produce high cylinder head temperatures. Not too much of a problem in the little Continental 0200. So just get used to slow flying around your aircraft. Trim it up and slow fly. Get very comfortable slow flying your machine. Keep your turns coordinated while you're slow flying. Just like Bob Ross painting one of those happy little clouds. Just get very used to and comfortable with slow flying your machine. Don't fear the stall. The aircraft is very well designed for benign stall characteristics. What are the ingredients of a spin, stall, and yaw? Severe uncoordinated flight can get you into a spin. But these aircraft are so stable that it takes quite a bit of effort to even get the aircraft into a spin. Even if it's in the spin, it's very hard to keep it in the spin as there may not be enough control authority to keep that wing stalled and keep the aircraft truly spinning. Most Luscombes usually spin pretty good, but I'm going to respect that 70-year-old airframe, even though this one's been completely rebuilt and had all these major structural members replaced. But we're not going to do any spins in the Luscombe today, at least not intentional. So just practice that slow flying. Look at that, 35 miles an hour. Flying just fine. Again, no stall warning horn on this aircraft. It's all built into the aircraft. The root of the wing stalls first, providing a nice buffet over the elevator and a good feel to the stick. Another gentle power off stall, just like you're in the flare. Flare, 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 flare. And there she goes. Recover. Now, what are they teaching out there in the field these days as far as stalls? Are they teaching just the beginning of the stall, or they want to get you into a good stall series? I highly recommend doing a good deep stall series with your aircraft. Now let's try a partial power stall. Let me get out of the sunlight here. Keep it coordinated. Slow fly it around. Just like you're out there doing a stall landing. Just move it around so that you can see a little better. out of the sunlight there. Alright, now we're gonna get that nose way up there and partial power and use that rudder. Keep her up there. We're way behind on the area of reverse command, where it takes more power to maintain altitude at slower and slower airspeeds.
So let's go to the whiteboard to review what I mean by flying behind the power curve, or flying in the area of reverse command. On the x-axis, you have increasing velocity. On the y-axis, you have increasing power. There are two types of drag in an aircraft. Parasite drag, shown on the blue line, increases with the square of the velocity. No matter how big of an engine you get on that airplane, eventually you're going to run into a wall of ever-increasing parasite drag. That's the same drag as sticking your hand out of the car window and feeling that air load as you increase your speed. Also on an aircraft wing is induced drag. That's this curve here shown in purple. That is the drag that is produced as a result of lift, such that the slower you go, the greater that drag is. And that drag can be visualized by seeing wingtip vortices on an aircraft. So you got the induced drag curve and the parasite drag curve. You put those two drag curves together and you come up with an overall drag curve that's got a low point right about here, and a lot of good things happen right about that low point. That's approximately your best range, your best angle of climb, your approach speed is very close to here. It's the point where the aircraft can be operated most efficiently. Anywhere ahead of this point, the more you increase the throttle, the faster you'll go. Behind this point is known as the region of reverse command. The slower you go, the more throttle you will need to remain airborne, to overcome the effects of induced drag. This area is also very important for STOL type operations. If you want to land with as minimal amount of energy as possible, just above your stall speed, right about there, you're going to need to operate in this area of reverse command very carefully. So on this side of the graph, it takes less power to fly slower, and on this half of the graph, it takes more power to fly slower. Thus, the term, the area of reverse command, the region of reverse command, or flying behind the power curve.
Right on the stall burble there. I'm locking those ailerons, full aft elevator, and we're just on the burble there. Rudder. Keep it straight with the rudder. Again, don't use ailerons. You're just going to mess it up and stall the thing right over. Use the rudder. Okay, there's 5,100 feet. Let's climb her on up. Cool off them cylinders. Remember what I said about 0 G's? You can't stall an aircraft at 0 G's. You're not loading up the wing. Anytime you add more than 1 G, you're putting a load on that wing, and your indicated stall speed will increase. You'll reach that critical angle of attack much quicker if you load up the wings. Remember, the aircraft can only stall at 1 critical angle of attack, but any airspeed at any attitude. So, 60 degrees bank, our max bank without a parachute here, like a little wing over, for example. Bring it on up to 60 degrees bank, but I'm not loading up the wings at all, even with the power off. It's just falling. Falling with grace, as Buzz Lightyear would say. Keep it coordinated on the roll out there. Little wing over to the left. I mean, look at that airspeed. I'm looking outside. I'm not loading the wings up at all. However, a steep turn maintaining altitude right up to 60 degrees is going to take you up to nearly 2 Gs. I got to pull like heck right there. And those wings are working hard. Look how quick that thing's turning. Look how much additional power I had added as well. Steep turns. Good practice. Keep that altitude. Keep it coordinated, Brownie. Boom. Great coordination exercise, Dutch rolls. See those Sutter Buttes out there? Let's just keep the nose on that. Don't worry about this ball coordinator at the moment. Just look at that point out there. Keep that piece of bubble gum on the point. Practice, practice, practice. The slower you roll, the harder the Dutch roll is. Great coordination exercise. It's kind of like the beginning of a slow roll. TFR ahead. Woo! Let's get out of here, boys. Okay, AQP stuff they don't teach you on the FAA written or private pilot's license. Engine failure on takeoff, define mid-maneuvering airspeed. You can do the math and come up with a good number. I like to use 65, about 65 miles an hour in this particular aircraft. But to me, it's more of a pitch attitude. I want that nose down. You get climbing up here, and you suffer some sort of an engine failure. Get that nose down right away. Look at that, 0 G. You cannot stall an airplane at 0 G. Okay, there's 65. There's my defined mid-maneuvering airspeed. I can now maneuver. I can turn this thing every which way, but maintain that 65. Maintain it. Maintain it. Maintain that 65 indicated. I'm not recommending a turn back to the runways per se. I'm just saying maintain that airspeed and fly this thing right into the crash. Then you get down there into a spot in between the trees, and then you can work on your everything that you learned here on slow flight and stalls. And just get it as slow as you can now that you've got it maneuvered into whatever position you got, and then blam, stall it into the trees. What, 40 miles an hour? You'll probably survive. Who cares about the airplane? It's off to the insurance company anyways. We just want to bring you back. And that's just how quick it's all going to go down. Stalls and falls in the mighty Luscombe. Nothing to it. Get used to it. Get comfortable with it. Do not be afraid of the stalls. Do not fly with an instructor that's timid of stalls. And I highly recommend spin training too. I don't know why they ever took it out of the syllabus. All of us in military training all had to do tons of spins and recover from them. And it should be a fundamental part of private pilot flying today. We see so many accidents of people stalling the aircraft in the pattern, and I bet you most of those folks have not gone out and practiced a full stall series in that aircraft. I don't care what, even if it's a high performance aircraft, get out there and regularly do these stalls. Just like going for a morning walk, I like to go for a morning flight. Come out here and do the stalls and falls series.
So get out there and practice your stalls and falls, get used to flying on the backside of the power curve, and watch your confidence and ability soar. And let's get this accident rate down, this completely preventable general aviation accident rate down, especially when it comes to stalls and spins in the traffic pattern. Completely preventable. Know your DMMS airspeed, do your takeoff briefing, and practice your DMMS procedures. Thanks so much for your support and your support over on Patreon that makes this content possible. See you here.